the surface, something with holes in it. You know, you can see there's a little bit of depth to it right there. And then I call this the Google Earth wheel, right, where you kind of back out and everything. You know, go in and out from your whatever you're looking at. You can see a ridge right there. It's looking a little more 3D. And as we back out, it starts to take shape, and you can see it's like a little screw, right, that we're looking at. And to give you an idea of, give you a sense of scale of what we're looking at, I got another one right here. We'll back all the way out so you can see the sample holder. But you can see that's pretty tiny, you know, what we're looking at there. It's basically just a little screw to hold on a plate. And the system makes it very, very easy to just basically zoom in and out of areas you're interested in. And you know, why would you be concerned about something this small and a tiny little screw, right? Well, if there's holes in this plating, this zinc coating on the surface, you could have corrosion of that screw, right, which could grow out and make it impossible to get out of its socket, so then the system can't be serviced, or it might break and fall out, then you've got panels that are popping off. So, you know, we have to take a very close look at even the small things, because they can cause really big problems if we're not careful in design. So we spend a lot of time looking at the little things, especially after the testing we do, right? So something gets beat up next door, we can go through and check resistors and capacitors and things for cracks and make sure that's not happening. The second benefit of this instrument is because we're using an X-ray beam here, things actually glow in the X-ray region, and we can pick that up with this detector over here. You can see it's full of liquid nitrogen right now. And get a spectral analysis of what we're looking at too, elementally. So not only can I look at the screw, I can tell you if it's coated with zinc, if it's coated with nickel, or if it contains a restricted material like lead, cadmium, or mercury. So we do quite a bit of environmental testing in this lab, and this tool is one of the things that we use to identify areas of non-compliance and during development, so we can fix that kind of stuff before it goes out. So anyway, so let's go out here. I'll show you a couple other things in the main lab. So the rest of the lab, we have a variety of chemical analysis tools. Most of these are, the idea is to basically generate chemical fingerprints of substances, and you can come a little closer out here if you want. Take a little closer look at everything. So we've got an infrared spectrometer, a gas chromatograph mass spectrometer. These tools basically sample materials, generate chemical fingerprints. They're used in a lot of different industries for a lot of different reasons, and we use them here to identify unknown materials, to verify that the materials that we are using are the ones that we specified, you know, that they meet our quality expectations. And then aside from all the chemistry, we do a lot of mechanical testing too. So I have this mechanical testing machine here and that one over there. To give you an idea of how these are used, they're basically very large measurement tools, right? So we can use these to measure a variety of things. And one of the things we were looking at is in considering new memory connectors, right? Everybody's familiar with memory connectors and basically inserting memory DIMMs in. You want to make sure that when you insert the memory that it doesn't take too much force to put it in, right? Because you can end up twisting or breaking the memory. The what now?
You can bend it.
Yeah, you can bend it and crack it, right? But you don't want it to be too loose either, right? Because then the memory could pop out of the socket, right, during shipping or some other event. And we actually take this one step further. Not only do we carefully insert with this tool and measure the exact amount of force needed, but after we're done, we'll actually cut these sockets open and look at the physical surface of the contact to make sure that it's intact, that it looks the way that we think it should look. These are gold-coated contacts, and if the gold is removed, you could have problems electrically. So we'll actually go the extra step, cut these open, and make sure that everything is fine inside the connector. And I'll show you something a little later on that's connected to that. I'm going to show you a tool over here, kind of jump around a little bit. This is something that we bought recently for doing environmental compliance screening in the lab. So we spend quite a bit of time and effort in this lab making sure that HP not only meets the legal requirements for substances of concern, right, but that we also meet our own goals, which are much stricter than even most laws have us do. So there's a huge list of materials that HP restricts voluntarily, and we go through and screen in this lab to make sure that those materials aren't in there, and we've got the greenest products possible. So this particular tool is a handheld X-ray spectrometer. So what we can do with this is basically hold it up to a surface, pull the trigger, and in about 1 second it'll give me a full elemental analysis. So it's kind of a tricorder, basically, right? For Star Trek fans, right? And it's very, very quick and easy to use. We've just got a stand for it too, so we can really get our throughput up. We've got a couple of these in the back room for doing analysis of new products as they're being developed. to make sure that they are compliant before they go out the door. So.
Wow, that'd be great for a prospector, wouldn't it?
Yeah, oh yeah. In fact, they sell these actually to a lot of these to the mineral industry, right? You know, to mining and stuff like that, so they can go through and sort, ores and that kind of stuff. So, a lot of different uses for something like that.
You're made out of water.
So Dave said that you would tell us the rest of the story with regards to an interesting customer situation for which we used what I'll call the chemistry and the science that we have in the lab here to solve.
Thanks for reminding me. Yeah. So so recently we had a customer that was having some issues with systems failing in their environment, and I think Dave told you about the beginning of it. It was unusual because they were the only ones having a problem with the system, and the power supplies were failing. So there was the power supply would fail, the system would shut down, and you were done. And we weren't seeing this anywhere else, right? So the systems were sent to this lab, and the first thing we did was go through the entire box and look for anything that visually that may have occurred on the board, right? Maybe there was something going on with one of the components on the board. Everything looked fine, actually. So then what we did is we took a residue test kit, and actually let me grab one because these are kind of interesting looking here. This is something, there we go, we can use some visual aids here. So what these are residue test kits, and they're very similar to what you'd actually find in a crime lab. And the idea is, you can see I got a couple bugs on there for high school tours and such. But what you do is you can take these little studs and put them down on a surface and pull up a residue from that surface, right? And then we can analyze it in the electron microscope and look for anything unusual. Well, one of the things we found, besides the normal office dust that you typically see in a computer system, were tiny little flecks of silver inside the box, especially inside the power supply. And so we took a closer look at the silver using tools like this and on the electron microscope, and discovered that the silver was actually a specific alloy of silver. It wasn't just pure silver. It had a little bit of copper and a couple other metals. We matched that alloy actually to a jewelry silver. So it's a very specific silver that's just used to make things like rings, right? So then what we did is I flew out actually to the customer site and took a look at their environment, did some sampling of my own, and discovered that the systems themselves were in what appeared to be a very clean area, right? A design area where people were designing jewelry, actually, which was kind of interesting. So walking around the facility, I noticed that there was a physical area where they were preparing the jewelry not too far away, and in that room there was a grinding wheel. And so I noticed some of the students over there were grinding away, at their jewelry and producing a lot of dust. And I watched some of the students walk out and go right into the computer lab, right? So what was happening actually was they would grind away, get the dust all over their pants, sit down, the computers were on the floor, and they would suck all of that dust into the system. And of course, you have metal particles in the system, they conduct electricity, and it was blowing out the power supplies. So we basically helped the customer rearrange their environment, rearrange their model for using the systems, and eliminated the failure entirely. So
CBS actually bought that storyline for CSI Miami or New York?
Yeah, right. New York, I think. Yeah. So that's basically what we do in the lab. The idea is to be the eyes and ears of the engineering community, to help them, again, look very deeply into any kind of puzzle that they're working on, be it just a simple design problem, or, like I said, situations where the customer is having issues in the field because of the environment that the systems are being used in. And the idea is to not just trust that the materials HP is buying to produce our products are good enough, but to verify that as much as possible, so we're sure that the quality is very high.
Any last questions for Dr. Paul?
Anything else? Well, thanks for coming in.
Thank you.
Paul, thanks as always.
Yeah, thanks, Terry. We'll see you around.
Yeah.
Thank you very much.